Hello, my name is Ash Hamid and I'm going to show you how to create the Shirdi Sai Baba temple using Grasshopper and Rhino 8. So what you have to know about Shirdi Sai Baba temple, that it's a pavilion in India and it has 11 gray panels that are highlighted in yellow, as well as 11 white panels that are highlighted in red, and it's above the gray panels. Started with creating a single unit from the gray panels by using points and then connecting them into lines and mirroring them to loft them to create the single unit from the gray panels, and then converting them into a mesh by using a simple mesh battery. In order to create the openings in the gray panel, we have to refine one of the pairs and offsetting it to extract the corner points as well as the normal of the surface by exploding it, and then cutting where we want to have the placement of the pattern, as well as using this place to extract the closest point to be acting as the center point of where we want to have the openings. And then welding it to create this as a one surface, as well as extruding it to the x-axis. As you can notice that each gray unit is actually repeated to be facing the center point of the polygon, and the polygon has 11 segments, and in each endpoint of the polygon it has a one single unit, gray unit. So after extruding the mesh, we've mirrored it to have the one unit of the gray panels, and then we've created the polygon that has 11 segments, and then we've arrayed the gray panels to be facing the center point of this polygon. In order to create the white panels, we have to understand its relationship with the upper circle that is divided by 22 times, and each white panel is actually connected by 2 points with the upper circle, and in compared with the gray panel where it's actually connected with the white panel and its upper point of the opening. So I've extracted the needed points from those circles in addition to its relationship with the gray panel, where we've actually extracted its relationship through connecting the lines and to add its further connection through the endpoints with the upper point of the whole, ending up with having a simple mesh of the white panel. To create this pattern on the white panels, we've actually followed the same concept where we've actually exploded the refined mesh to extract the mesh corners and the normal of the surface to make it act as the area or the center of where we want to have the patterns or the frames, in addition to having the same logic where we wanted to use the cull index to define where we wanted to have the pattern, ending up with extruding it to the Z direction and arraying it along the upper circle to make it facing the center of the upper circle. In order to create this column, we're actually generating the form through extracting the negative space to create this form. Basically, we're getting this pattern, the diamond pattern, then we're getting the Rhino out of it, and then we're rebuilding it to get a smoother, even shape. And we are defining here by the closest point where we want to extract the negative space, which are those. And we're selecting where exactly we want the negative space that generates the form of the column, and then by trimming it, we're getting actually the form, and we're connecting the endpoints out of it to end up with generating the column. In order to create this flower shape on the circle, we've had connecting them through points and lines, and then piping them to create this flower shape. As for the kangaroo simulation part, we're actually controlling the white panels to make it even more bouncy. So basically, we're controlling we're welding and unifying the normals to make sure that it's well oriented, and then we're taking the endpoints of the white panels as an anchor, as well as the other goals, and controlling the bounciness through the load, ending up with having this bounciness on the white panels.